Okay, so today we're going to continue right along with your Rhino education, trying to build up a certain skill set such that you can go off on your own and start to make your own things. And because of that, we're going to spend the next 2 days building something scripted. So I'm telling you what we're building, I'm giving it to you, and I'm going to walk you through step by step how we're going to build it. We'll build this piece today. We'll build another piece next class. You need to make sure that you save these pieces because ultimately we'll combine them. But for right now, we're just going to concentrate on the piece for today. And like I said, it's really a skill builder. It's teaching you certain commands. It's teaching you how to work. And part of today, the way that a certain part of this comes together, it's going to teach you how to fix problems. And that's another piece that's always a little bit on the challenging side. So I will walk through it step by step so that you guys can see it. Obviously, I've written out a bunch of step-by-steps in here, referencing things that we've already done, like rotate 3D, for example. There'll be a little bit of coordinate systems in here today as well. So I'm going to start first by drawing the shape that's in the bottom of your little handout here, this shape. We're going to draw that. And I'm going to place the starting point at 0, 0 where that little arrow is. And I should probably bring this up on the screen so that you guys could see this. There we go. Of course, it's miniature, right? See if it's any bigger here. Well, not really. This point right there is the point that I'm going to make 0, 0. So that's where I'm going to start. So I'll start with the polyline tool. Right here, it's the second one down from the arrow. And I'm going to start at point 0, 0. I don't have to, but it's convenient to start there. So I'll type in 0, 0. The third 0, the z value is assumed at this point. And I'm going to draw straight up along the y-axis for 36 inches. So let me go ahead and turn on ortho here so that I'm locked into the 90 degrees. And I'm going to go up by 36 inches. So I'll type 36 inches and hit enter. And there I am. Next thing I'm going to do is go over by 4 inches. So there's my 4 inches. Now the next line that I need to draw goes down 36 inches and over another 2 inches. And so thus far I've been just, direction, distance, etc. Or I guess I should say distance and then direction to get to where I am. Here's a perfect opportunity to where if you use that coordinate system that we talked about on the first day, I can do the next step in one step. So all I would have to do is say at -2 inches, comma, -36 inches. Remember, the at sign is relative to the last point I clicked. I want to go -2, so -2 in the x, -36 in the y. I'll hit enter, and there's my sloping line. If I didn't do it that way, I'd be stuck saying, oh, well, let me create a guide that's 36 inches, and there it is, and let me go over 2 more inches. Okay, there it is, and then let me create another piece that goes from here to here, and then I could join that in with everything else. So it's a lot of extra drawing that's really unnecessary. So if you get used to the idea that that coordinate system can be beneficial, you could just say at -2, comma, -36 and get there. So I'm going to continue on as I go around this shape, and I'll do this again. We're going to go -6 inches, so that's just the direction. Distance followed by a direction. There it is. This next piece is a slope again. So in this one, I would be going at 30, comma, -6. And that gives me that piece of the slope. So I'm flipping into using those coordinates because it makes it easier to draw, and it makes it only one step. Yeah? Sure. How about if I just do the whole thing again? Okay. Sounds like a good plan. All right, let's try it one more time. Repetition is always a good thing. I'm going to start at 0, 0, enter. I'm going to go my distance first, so 36 inches. And then I'm going to choose the direction. It's going to go straight up that y-axis. So I'll click one more time. Now I need to go over by 4 inches. So I'll type 4 inches, enter, and my direction, I'll click in that direction. The next part, this is what you were asking. Yeah.
Mine keeps going.
Are your units set to inches?
Yes.
I'll come help you in a little bit. Okay, so at this piece, we're going to do the relative coordinates. So relative to that last point that I started, we're going to go over 2 and down 36. So I'll say at -2, and it's negative because I'm going in the negative direction along the x-axis, comma, -36. So -2 inches by -36, and I'll hit enter, and that gives me that sloping line right there. So you guys see, obviously, that I gave you this because it's a little complicated. So I'm pushing you a little bit. That's the point. So I'll continue by going down 6 inches. So I'll type 6, enter, and a direction is going down. So I click. Next one is going to go over 30 inches and down 6. So again, I'm going to use those relative coordinates, and it'll be at 30, comma, -6. Now I'm not putting the inch signs in because my units are in inches, so the default is assuming inches when I type these values in. I'll go ahead and hit enter, and that gives me that part of the slope. Now I have to complete the shape. This is half the shape so far. So I'll say at, this would be 30 inches again, but this time it's positive 6 inches. So at 30, comma 6. And then I can continue by saying 6 inches in that direction. I need to go over -2 and up 36. So at -2, comma 36. Enter. Over 4. Oops. Try that one more time. 4 inches. Nope. So you see how I keep having issues with that line? It's because I have a point established over here that it's snapping to. So I want to make sure that point goes away. It's a smart tracking point. Let me make sure that point goes away. And I get rid of those by hovering over the points. Let's see if it'll do it for me now. There we go. I got 4 inches. It doesn't look like 4 inches. Try that one more time. 4 inches. There we go. Give me 1 second to finish this out. I'll go down 36 inches, and then I'll finish by snapping back to the start point right there. Yeah?
How do you make sure it's in inches?
So with nothing selected, right here, down at the very bottom, I know it's behind my head, it'll say inches. Yours might say millimeters. That's the other one. If you're unsure, you can always type units, and it will take you to the Rhino units, and your model unit should be set in inches. So I'm going to do that shape one more time. I'm watching where everybody is. Okay, so let's try it one more time. I'm going to start this at 0, 0. So I have the polyline tool selected. I'll start at 0, 0. I'm going to go up by 36 inches. So the distance is 36, and my direction is straight up the y-axis. I'm going to go over by 4 inches. So I'm going over by 4 inches. There it is. Next point is over -2 and down -36. So it would be at -2, comma, -36. Enter. That gives me that slope. Next piece would be going down 6 inches. It's going straight. Next piece is going to be over 30 inches and down -6. So at 30, comma, -6. There it is. Going back up, this would be at 30, comma 6. oops, helps if I type correctly, at 30, comma, -6, at 30, comma, 6. We'll go straight up 6 inches. Now, this would be at -2, comma, 36 over 4, back down 36, and then over to finish the shape. And so in my case, it was one continuous polyline, and I ended up closing the shape. If you end up making it of pieces, that's okay. You'll just have to join those pieces together, ultimately. And there's nothing wrong with doing it as separate little lines. So now that I have this shape established, I need to get it into the third dimension. So I'm going to use my rotate 3D command to rotate 3D around this line here. So I'll go up to my transform and choose rotate 3D. Or I can type rotate 3D. Remember on the handout, whenever I use that typewriter font, it means you can type that in. And my rotation axis is going to be this line from here to here. And my angle, or first reference point, is going to be going out to the side. And I'm just going to fold that one up into space like that. So one more time, rotate 3D. There's my object, enter. Start of rotation axis is going to be along this base here, end of rotation axis. My first reference point is along the length of this side, and I'll fold it up into space. Now I have ortho turned on. If I didn't have ortho turned on, it would rotate to any angle that I wanted to. I would have to hold down shift to get it to jump to that 90 degrees. I'm going to come around and see how you guys are doing. I feel like I've got a lot of people who haven't gotten there yet. So let me pause. I'll come around and see if I can get everybody here, and then we'll keep going. OK, so I think I got most of you caught up to this point. So I'm going to go ahead and continue on making this 3D.
Sorry, can we patch everything individually, or do you want us to count?
You could patch it. I'm going to do it with 3 or 4 corner points. I'll show you in a second. OK, so now the next piece of this is I need to offset this curve, so I have a second set of this curves behind over here. So I'm going to type in offset, set, curve. Excuse me, it's just offset, just plain offset. And my distance, I need it to be, what did I say, 48, didn't I? There it is, 4 feet, so 48, or 4 feet. I'll hit enter there. And you see by default, I am going back in this direction. It's possible that you will get this result, where your offset is going around your object instead of back in space. If that is the case, when you do your offset, check the option here for in C-plane. Do you want it to be no or yes? In our case right now, we want it to be yes, which will cause it to jump back versus jump out. So most of you probably have yes by default, so I'm not overly worried, but I like to point that out because I've seen people get stuck on that before. And I'm going to basically make a copy of this line going back in space in that direction. So I have 2 of these little lines together. Now on the directions, I told you to go ahead and explode these 2 parts. The truth is you don't have to, but it's good practice too. So I'm going to go ahead and explode these. Not good practice in terms of you'll want to do it all the time, but good practice because on the loft command you're going to do this a bunch of times and get used to it. So essentially at this point I'll take the 2 opposing lines, so those 2, and I'll type loft. Default options are fine, and I've now created that first surface. I'll take the next 2 lines, there and there, and I'll repeat the loft. So again, I could type loft, or I could go to surface and then loft, and I make my next set of lines. Or I make my next surface. I'll move up to the top here, there to there, repeat the loft, and there it is. The other option to this would be if you left them connected together. which case it would be the same as if I joined these back together. Join. Then I could loft these all in one operation. So the only thing you have to pay attention to on that loft, let me do that for you. Now they're all back into closed curves. When I do the loft, it's going to ask me where the seam occurs and what direction I'm getting my loft. So in this case, these 2 points are on the same spot, and they're going in the same direction. If I were to move one of these points, so if I took this point down here, for example, when I do the loft, it's going to give me a kind of a wonky result because the loft isn't even. It's starting on an angle. So let me go back and cancel it. Let me repeat the loft. Likewise, if I had the directions changed, oops, come on. Maybe this one will change directions for me. Doesn't want to change directions on me, but I would get similar results. So you just want to make sure that these 2 arrows are starting at the same points and going in the same direction. And you'll end up creating that shape. Okay? So there are, of course, other ways to go about doing this. And you could, for example, extrude one of these curves to get a shape. That would be another option. So there's lots of flexibility with how you create it. I'm just trying to practice with the loft command for today. So now that I have those surfaces all the way around, I need to create surfaces on the ends. And so one of the strategies certainly would be to cap this shape or to patch this curve at the end. The problem with those comes later on, and that is we're going to end up causing some bevels and we're going to have trouble. So instead of that, I'm going to make smaller little sections. And you guys saw that on the sample, I actually drew little curves in there and there. You don't have to draw those little curves in, but they can be beneficial. Okay? What I'll do instead of using the patch, on the handout I think I say use patch. I'm actually going to do the surface from 3 or 4 corner points. It's this one here. And I'm going to click on 1, 2, 3, and 4 to create that surface. I'll repeat the surface from 3 or 4 corner points and do this little triangle in the corner, 1, 2, and 3. Next one I'm going to do, we'll go 1, 2, 3, and 4. And then I'll repeat going the other direction. 1, 2, 3, and 4. 1, 2, 3. Enter. 1, 2, 3, and 4. And there you go. So those allowed me to fill in the end. And yes, right now they're all separate, but it's going to make a difference a little bit later on. So I could go and come to the back side, and I could do the same thing with my surface from 3 or 4 corner points. Or I could take all of these surfaces, I'm holding down Shift to select them all, and I could copy them using transform copy from this end to the back side right there. I could also mirror the objects along the center of the shape. So there's lots of flexibility in how you do this. Okay? So now that I get to this piece, it's now time to start beveling the corners. So this is a little piece of a concrete bridge, a walkway. And we're going to bevel the corners so that if we were actually doing this in real life, we wouldn't have 90-degree corners that would cause breakouts when you took the forms off. But that's a construction thing, not a practice thing. But anyway, we're going to go ahead and bevel these corners. So I'll start right over here with this side. And to do it, I'm going to use the surface and then chamfer surfaces. The key command is chamfer surf if you want to do it that way. First thing I need to do is set my distances. My distances aren't going to be 1 inch. They're going to be a ½ inch. So I'll type 0.5 and then 0.5. So my distances should read 0.50 and 0.50 on my 2 distances. Extend yes, and trim should be set to yes. Those are both default options. Once I have those things set, I'm going to click this surface followed by that surface. And you see how I get that nice little bevel along the edge. I'm going to do the same thing all the way around. So we'll go chamfer surface again. So I could type it or go to surface, chamfer surfaces. My distances stay the same, and I'll do this end to that end. I'll repeat the command. I right-click to repeat this to that. So if I look at this corner, though, I've got this little piece that's kind of hanging over and hasn't trimmed quite right. So there's going to be some cleanup that I'm going to have to do. Furthermore, when I chamfer this surface to this surface, it gets even more nasty. So I've got those corners. They're just kind of a mess. Let me do it for this interior here. We'll go there and there. And so those are going to definitely require some cleanup. So this is part of today is learning how to deal with these kinds of issues. And so I've got this nest in the corner that I need to clean up. I'm going to use the trim command, but I need some guides to help me with where I do the trim in the first place. So I'm going to use my Polyline tool. And don't worry, I will repeat this a couple times. And I'm going to make a little triangle. I'm going to go from this corner to that corner, down to this corner, and back over, which creates that little triangular curve right on the end. I can then see how when I'm trying to orbit, see how my piece tends to move away from me as I'm trying to orbit. That can be extraordinarily annoying to work with in your modeling. If you want to recenter your view around a particular object, so in this case this little triangle, you can press Z followed by Enter, which gets you into the zoom command, and then choose S or choose selected, type S and Enter or choose selected, and it will recenter your view around that triangle now. So I don't have that weird jumping rotation anymore. I'm centered right around that piece. I need to trim these extra pieces. So with that selected, I'll go into my edit trim, or I'll type trim, and I'll get rid of this piece and those little pieces. I'll get rid of that piece and this piece, and now suddenly I'm left with a nice clean edge. I'll hit Enter to finish, and then I can do that surface from 3 or 4 corner points, 1, 2, and 3, Enter, and it gives me that little surface on the end. So that's much cleaner than this corner, which isn't very clean. So I need to do the same thing. It's going to be a little triangle on that corner. So I'll go in here to my polyline. I'll go from there to there to there, and I'll close my little triangle. There's that triangle. And I'll now go in and trim these extra pieces off. Now they're all nice and trimmed. I'll hit Enter, and I'll do my surface from 3 or 4 corner points, 1, 2, and 3. Enter, and now that's filled in as well. So I've done these upper 2 corners. I obviously have to come over to this back side and finish my chamfers. So chamfer surface, there, 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 and there, and there, and there. So I've got the same 2 little nasty corners to deal with. As I come down here, I need to do the chamfer surface from here to there, and you see that that lines up nicely. If I had done this in one big shape, it wouldn't seam as easily right there. I'm not going to worry about this joint. We're not going to do that one. But I am going to do underneath. So I'll chamfer surface underneath there to there, and I'll chamfer surface here to here. And they meet nicely here, but they don't meet nicely right there. Oops, there's a little gap. So we're going to have to fix that problem, and I'm going to show you how to do that in a second. But before I do that, I want to come around and see where everybody is. So I'm going to pause, come around, see how everybody's doing, make sure they got to a shape, and then we'll continue. If you feel comfortable and you feel like you've gotten to a good place, keep working on your little corners. and just pause on this lower corner until we get to that point. Okay, so I'm going to continue. Some of you aren't quite here yet, but that's okay. I've noticed enough YouTube videos pop up to know that it's time for me to move on and show you the next part of the puzzle. So the challenging corners start to come when we get down to the bottom edge here, because it's on a slope, and we end up right here with that little gap. And so I like to bring up 2 points. Number one, if I was rendering this, imagine this had a texture on it, and I was rendering it from this far away. Could you tell that it had a little gap? Nope, not at all. So if your desired end output is just that you want to do a rendering, spending your time correcting that is not worth it, because you're never going to be able to tell in the rendering. However, if you were going to 3D print this object for some reason, that little hole would cause it not to 3D print. So in that case, it is important to correct it. So just be aware of the intended long-term output. If you wanted to 3D print this, obviously you'd go in and make that correction. If you don't care about 3D printing it and you're just going to render it from far away, not a close-up detail shot, it's not going to make any difference. So be aware of that. For our purposes today, learning how to fix it is still not a bad idea. And so as I look at this little corner, we have a couple things that we can do in terms of fixing it. And so I will do it on two sides, and I'll do it differently on both sides. So let me chamfer this other surface to end up with the same problem on each side. So they're equal, so you can see different ways of fixing it. So the first and probably easiest way of fixing it would be to draw a polyline from that point, that end point, down to the corner at the bottom, which gives me that little line right there. And then I could trim the excess surface from that. So I'll type trim, and I'll get rid of that piece of excess surface. It still means that I have a problem with this surface. There's still a gap there. I've just elongated the gap. Instead of being just in the corner, it now continues along. But I can just take this surface, delete it, and create a brand new surface from 3 or 4 corner points. 1, 2, 3, and 4. And when I do that, this newly created surface goes to those 4 points. But instead of being perfectly flat, it's actually twisted just a little bit. And there's nothing wrong with that, but it has a little bit of a twist to it. And so now it's a nice closed, seamed line there. So that's one method of fixing it. The other method of fixing it involves turning on what are called control points for this surface and manipulating the control points on this surface. So to do that, and again, this is the more advanced way of doing it, so I'm not expecting that you necessarily choose to do this method, but I at least like to show it to you at this point. We have 2 options over here. We have something called points on, and we have something called edit points on. And depending on whether it's a surface or a curve, one or the other of these is more or less useful. So in our case, I'm going to select this first surface. Let me select this surface, actually. And I'm going to turn on my points. And there it is. And it gives me this little point on the end, this surface point. I can move that surface point to line up to that object here. But you see how this point extends beyond where my surface is? This point controls the untrimmed object, and this object has been trimmed when I did the chamfer. So we're actually going to use a command called untrim, which is actually a really cool command. If you trim something and you don't like it, you can untrim it. And I'm going to untrim that edge right there to get my full object back. Now I still have that little point on the edge. I'm going to move that from right there to right there. And now that's fixed at that corner. I'll come in here, I'll manipulate this corner. There's my surface point. I'll move that to right there. So I'm essentially editing where the corners of the surface are at this point. I can do the same thing with this surface. I'll turn on my control points. I need to untrim that edge. Untrim that edge there. Then I can move this. Oh, come on. Let me have it. There it is. I can move that surface point to where it matches up there. I have to make, looks like there's an issue in the center here where those two didn't quite intersect, one or the other. There's two control points along the center of this, and I need to move those to match too. So let me snap that over to perpendicular, and I'll snap this one over to perpendicular. So this is a surface level correction where I'm actually editing the surface itself. So I didn't create any new surfaces, I just manipulated the existing surface. And so like I said, this is a much more complicated way of going about fixing it. The trim is an easy solution. But I like to at least introduce the concept that you have control over the surface. So you can turn on the points of the surface if necessary. Whoops. There's my points on. Now I see those 4 corner points that I can then manipulate. So just be aware that that exists down the road because we may want to turn those on for certain objects. So that was 2 different strategies for dealing with those lower corners, which are the biggest mess of this whole thing. And so what I'll encourage you to do is make an attempt to fix the corner. Make an attempt to fix one of the corners. And if you can do it for one of the corners, great. Okay, this is, again, a learning process. Remember, it's a pass, not pass thing. You work on it, you learn from it. You get credit for it. Okay? So I'd like to bring out one more thing before I help people, and that is that if I personally were modeling this particular shape, I would do this in far fewer steps than you guys are currently doing it. And so I want to show you how I would go about doing it because I think it's important for you to understand the thought process behind it. Okay, so in this particular object, there are a lot of similar pieces to it. So I could really get away with just modeling like this. So let me say, let me turn on my ortho for just a second. 36, 4, at negative 2, comma, negative 36, 6, at 30, comma, negative 6, and then I could finish it like that. So it's only half of the original shape. Then I could take this piece, rotate 3D, rotate that into its place. I could then offset this, not by 48 this time, but by 24, which gives me that part. I could take this and this loft to give me that shape. Surface from 3 or 4 corner points. Like that. Then I could do my chamfer surface. Okay, so I've got all those points done. Oops, I got to do these side ones. There we go. I'd fix these corners. You guys don't have to watch me fix the corners. Okay? Fix the corners, fix the bottom, and then I can take this shape and just mirror it that direction. I can take this shape and mirror it that direction, and I've now created the whole shape. So I built a quarter of it, and then through some mirrors was able to create the whole shape. So I've only, well, you guys would be theoretically going through 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 corners. I did 1, 2, 3 and got to the end. So when you're thinking about modeling down the road, you want to also think about what efficiencies can I use in the process. So how can I cut my work down and use the tools that you have to make that a little bit more efficient? So in the course of today, I didn't have you build a quarter and then mirror it because you need the practice. You need to learn how to do this stuff anyway. So repeating these corners over and over again will help you learn how to model. But at the same time, I want you to see that there's an efficiency to the process. Okay? Does that kind of make sense? So Give these lower corners a bit of a stab and see how they turn out. If you need help, obviously I'll float around. Once you're done with this, make sure that you save this file because we're going to use it again in a later class. I want you to apply a material to this. So we'll go ahead and go up to our V-Ray materials. Load up something like concrete probably. So go to load material, go to your V-Ray materials. I don't know if mine are currently on the flash drive right now. Yeah, mine aren't. Mine are syncing right now, so they're not there. You'll load it in, and then you'll apply the material to the selection so that you have a material on your selection, and then you'll do a render. You may also want to set up an infinite plane, which we've done before. I don't know why my V-Ray toolbars aren't here. It's the key command is viz infinite plane if your toolbars aren't there, or you can load the toolbars. You may want to set up a little directional light and then do your render. Those parts are optional. I at least want to see this as a concrete shape by the end of class. You're going to post that at the end of class today. Nothing else fancy, just this particular shape. So spend the rest of your time today wisely and really try to learn these techniques. Like I said in this class, everything kind of builds on itself. So you look at what we're doing, there's already a rotate 3D, there's an offset, there's a loft. We've done all of those already in class. So we're just kind of building up our skill set. Next class, we're going to build something different using completely different strategies that you haven't seen yet. All right? I'll come around and help you guys.